Okay, press the go live button. Will be live in some time.
It's live, right?
Yeah, it's like
Okay, so let's start. Greetings, everyone. I'm Purvi Vesh, a member of the organizing team of HackStack. And as everyone knows, blockchain is the most in demand job skill in the market. Yet, the path towards getting into this field is cloudy, ambiguous, and uncertain, especially if you're a student trying to explore blockchain for the very first time. So, with HackStack, just a few hours away, we are here with our first speaker session to help you break into blockchain with Jobin BA, who is currently a blockchain developer evangelist at Arcana Network. So, before we begin with the session, Jobin, could you please tell us more about yourself and how you got into this exciting domain of blockchain?
yeah. So I've been in developer relations field and a lot of different developer communities for a couple of years, and I was a great I was a great what do you call a guy who focused always on privacy and security. Because I believe there are a lot of tech companies offering you a lot of products and services, but instead of the free services, they steal your data. I believe data is the most valuable thing on internet, which is used to manipulate you to buy things that you actually don't need, or sell to you services that you don't actually need, track you, and this is interfering with somebody's privacy. So uh, when Web3 came, when blockchain came, I saw the potential, and I saw how this could solve the major issues with internet, how it can turn the centralized system in the internet to a decentralized system, which would hand over the power back to the users of the internet rather than just the big tech companies or tech giants holding the power of all the internet. So that's how I chose to venture into blockchain, and I started from the basics a couple of years back. So it's around 2 3 years back when I started Web3. I started learning Solidity. I started building a couple of projects, NFT projects, and a lot of stuff. Then that's when I came across Arcana Network, which was also having this motto of privacy and security. That's what we provide right now. Also, data and privacy stack for Ethereum applications or the apps. So that's about me. So
Yeah, thank you, Jobin. It was really nice. So, all right, then let's begin with the session and break into blockchain. So, Jobin, over to you. You can carry the session forward.
yeah. So before starting, thanks to the HackStack team for organizing such an event, and for also for the hackathon, and hope that we get some really good, awesome projects built in this hackathon. Yeah. So before moving on to our deck that I'm going to share with you, which will give you an idea what exactly blockchain is and how you could break into blockchain. Uh, so, like I said, Arcana Network is the organization for which I'm working, is the sponsor for this hackathon. And if you wish to build a project where you need to require a solution for storage or authentication, then for sure you can check out Arcana Network. It lets you easily set up. It's very easy, far easy than any other services for setting up like storage or authentication. That basically requires 4 or 5 steps, and you are good to go. It's around 30 seconds or 40 seconds for you to set up the backend for the storage and authentication. That simple it is for you, so you don't have to worry if you're building a project which needs storage solution and authentication based on blockchain. Okay, so you don't have to compromise uh, what do you call privacy or security just because you're not able to build on blockchain because it is very complicated. The UX or UI is complicated. We have the solution for it. Yeah. So I'll share my screen. Yeah, I hope that screen is visible. Let me just confirm the same.
Yes, it's visible.
Yeah. Awesome. Awesome. Yeah. So you can see right now on my screen what's the hype about. So it's notes, gas fees, day apps, proof of work, proof of consensus, lot of like different types of consensus, all this stuff. Okay, so all this is called as blockchain, and blockchain is the central, what do you call, the major technology behind all these words that you see. So we are going to be breaking into this technology. We are going to be trying to understand. We'll try to understand how this technology works and what does and how it is useful. Okay, so the difference between any other session and this session is that I'm not going to be explaining to you with any sort of technical definition or technical content, but I'm going to be explaining to you in the most simplest way in layman's term. Okay, so yeah, so here we go. Yeah, so this is blockchain. Okay, so this is the definition that you will see when you the simplest definition that you will see when you try to understand what exactly blockchain is from internet. You will see this is the simplest definition, the smallest and the simplest definition that you can get, and illustrations how a blockchain might look like. Yeah, so can you guys yeah, so this is how it looks like. So you can see different blocks or different cubes which are interconnected to each other. So this each and every blocks are nothing but blocks containing data. So this is how a blockchain looks like, but this doesn't make it simple. I want sharing this. Yeah. So you can see in simple words, blockchain is like a sequential chain of coaches in a tree. Yes, you heard me right. A blockchain is very, very similar in terms of its structure and as well as its working to a train. Okay, it's very similar to that. And how it is similar, you can see the illustration on the screen, how a train looks like. And what all things train have. Train has got a coach in things. Okay, and how it is similar to a blockchain. Here you go. This is a similarity. So in train, you have got coaches. You have got multiple coaches, like the definition stated. It's a sequential order. In a sequential order, coaches are arranged like S1, S2, S3, S4, S5, S6. In a sequence or in a are arranged. Okay. In blockchain also are something instead of coaches. Like instead of coaches, we have got something called as blocks. The train blocks are sequentially arranged. Block 2, block 3, block 4. It's in a sequence in a exactly similar to train. Okay. So instead called as blocks. Second, the first coach, it's not exactly a coach in train. It is the one which pulls all the successive coaches with its power. The engine is the one which is an express or a mail or a goods or a passenger, because the what do you call, the engine uh, with respect to the type of the train. Like if you have got a mail or if you got a passenger, if you have got a goods electric and you've got diesel, different ones. So engine basically determines what type of coaches is it pulling. So similarly, instead of engine, instead of the first coach, we have got something or a genesis block. Genesis means beginning. So the beginning block in a blockchain, in a sequence of blocks, the beginning block is called as the of engine and train. In blockchain, we have got genesis block. Okay. And third thing, in train, identify each and every coach so that you can easily identify your train tickets and you can travel. Uh, is there some sort of networking? Yeah. So I hope that my audio is clear right now.
Yeah, it's much clearer now.
Okay, thank you. Yeah. So as I explained, instead of coaches in train, we have got blocks which are ordered in a sequence. It's ordered in a sequential order. Then instead of the first engine that's present in train, we have got Genesis block. Genesis means beginning block or the first block in a sequence of blocks or in a blockchain. Then we have got coach number in train so that you can easily identify according to your ticket and which coach you have the seat and you can travel. So for you to fetch or find out the right coach and right seat, you have an identification mark on each coach called as the coach number. Similar to that, we have got hash of the block. Hash of the block is the identification for each and every block. It's like your roll number. So if you might have a roll number like IIITMG 2022 102. So it's a combination of strings and so similar to that, letters and numbers. We have got identification, like each of you have got identification in your class. Similar to that, we have got identification of text and numbers. Okay, and it is derived basically by the combination is decided based on the number, the block number, the previous block number, and the data. It's like your roll number is determined by in which college you study, in what department, and your name. So all these factors determine your roll number, and based on all these things, a combination to you. Similar to that, here also the hash of the block, the identification of the block, the combination is determined. What was the previous block's hash? What is the data stored in the block right now? Which block is this? All this data is taken into consideration, and the hash is created like a formula or algorithm for that. Okay, so that is called the hash of the block or the identification of the block. Then, like in train, we've got something called as previous coach number. This is for you to move between the coaches while you're in transit without getting outside the train. So you might be in S3, you want to move to S1, have to have a understand. You need to check somewhere and see the identification mark, which one is the previous coach, which is the next coach, and based on that, according to the directions, you can move between the coaches. And this identification marks are basically at the entry or exit points or the joining of this different bogies or the coaches. Okay, similar to that, for you to easily identify the continuity of the blockchain, like if you are on the second block, for so that you can understand that the previous one is the first block, next is the third block, and accordingly you can fetch data so you can understand the order. You also store the previous block's hash number. It's like, you know that in front of you the block is block number 4, I am fifth number, and the next one is the sixth number. So that for easy identification, so for the easy getting idea that the what's the order, for easily getting that idea, we store our own identification or our own hash, also the identification of the previous block or a hash of the previous block. And one of the most important thing, that trains are used to carry passengers from one place to another place. Okay, on like in this world, from one place to another place, passengers are carried using blockchain. So similar to that, using train. So similar to that, blockchain is used so that you can carry data in this internet from one place to another place. Like you store the data and you store somewhere sitting in Mumbai. Then if you want to access it in Amsterdam or US somewhere, then you can do that. Okay, so what do you call easy movement of data? You store the data in blockchain and easily you can access it from anywhere. Okay, that's why it is used. Blockchain is used. Okay, these are the similarities between a train and a blockchain. Coaches, blocks. Engine, Genesis block. Coach number, hash of the block. Previous coach number, hash of the previous block. And most important thing, instead of passengers, you have got your own data that's stored in each and every block. Okay, yeah, that's one thing. So next, what you have to do is, back in 1980s and 1990s, when the train was created, very few people used to travel in train, but more and more people started becoming aware of this transportation mode. Technology developed, so the demand also developed. More and more coaches had to be added for that, for meeting the requirement or the demand. Okay, so similarly, more and more data had to be stored, and so you needed to create more and more blocks in the blockchain. So how a new block is created and added, like how a new coach is added into a train. Okay, so how it is done. So creating new blocks. So in train coaches, Basically, a train coach is created by a coach factory, like the integral coach factory that's in Erode or in different places in India. They create this coaches in a proper way with all this, what do you call, proper layout and proper structure, like with seating and everything. Okay, they know how the coach looks and they create this coach. Okay, and some sort of mechanical work is involved in that. Similarly, for creating a block, you know how the structure looks like. Like you have to store, you have to have a previous hash of the block before creating a block. You have to have your own hash of the block. Then you have to have your own data also. So you take all these three things, and you know how is this? This is how the block looks, and you create a new block. Okay, and here instead of the mechanical work, computational work is involved. What computational work? And creating coaches is now known as manufacturing. Okay, it is known as manufacturing. So in blockchain, it is not called as creating blocks is not called as manufacturing. It is called as mining, and here instead of mechanical work, computational work is involved. Just one simple differentiating factor is that when you create coaches in a train, you don't create them with passengers. You create with a proper seating and arrangement, and people come and sit in the train after it's been added into the train. Okay, but in blockchain, the block is created by default with the data itself. So it's like you add the data and you seal the block. So like once the passenger gets in or the data gets in, it can't get out. So like you open the door, you push all the data inside it, and mark that what the block number is or what the hash of the block is, and everything you mark and paint and decorate it, and you make the block, and then you lock it. So once the data goes inside, it's stored. It's permanently locked inside that. Okay. That is what a block looks like, and that's how a block is mined, and computational work is involved. The computer is used to create this, because computer has to understand the structure, how it should be created, what all hashes should be calculated, how much data can be stored, all these things. The computational work is involved in this. Okay, so I told you, once the passenger goes inside this blockchain's block, the door is locked and you can't come outside. So this feature is called as immutability, or immutability in simple terms is that you can't change anything. Once it's stored, it's like once you have signed, you can't change it. You have agreed. Okay. Once you have wrote something, you can't cut it. You can't erase it. It's there, permanent. Okay. That is immutability. So once you have stored the data inside that, it's forever there, permanent there. You can't manipulate it. That is what provides this. This is the most essential, important feature that provides blockchain with something called as security. Okay. The security of blockchain comes from this one thing, which is immutability. Okay, yeah. So this is one thing. This is how it is. Blocks are created. Okay. So like when a coach is created by the ICF factory, a lot of people, a lot of work is involved. These guys are paid for that, right? These guys are paid for that because of their mechanical work involved. They are paid for that. Similarly, when you mine a block, the person who is spending his electricity using his computational power, he also gets paid as a reward, and that is what the Bitcoin is. Okay, the Bitcoin and all the blockchain tokens that you see, that are basically the rewards that you get for mining a block and adding it to a blockchain. Okay, so that is what you get when you get a Bitcoin. When what you should do so that you can get a. Okay. So you have to do some sort of work, mine a new blockchain, you will get the money. So the thing is that there are a lot of people, like it's not like ICF that in India only ICF has the permission to build coaches, right? But actually in blockchain, anybody can come and build blocks if they have adequate computational power. So we want people to avoid messing up with the network. So we have got a couple of systems to keep all these things in check. What is that? Okay, it's like you can't come and create some faulty coaches for the train and people will die while traveling that, or meet some accidents. So you have to avoid that. Government checks that. Okay. So similarly in blockchains, so that people misuse this and add malicious data into this, compromise the blockchain network. We need to have a system which can keep all these things in check. Okay. So that is called as consensus. Consensus is nothing but consider your college, like the IITM guys are planning to go for a trip to Shimla or Goa. Okay, so like people, you guys have two options. You want to go to Goa or Shimla. So like majority the people in the class will decide. So if the majority of people come to agreement that you want to go to Goa, so you guys will go to Goa, and the ones who chose Shimla will not be able to go to Shimla because the majority has chosen to go to Goa. So the coming to common agreement using majority is called as consensus in blockchain. Okay, the common agreement stuff is called as consensus. Consensus is nothing but simply coming to a common agreement to take a decision. Okay, so what's the decision here? So as I told you, anybody can come and mine a block. So it's like anybody can misuse it. It's like YouTube. You can come and publish any sort of video, but even YouTube has its own systems to check whether a video is right or wrong, you published any wrong content or not. Similarly, the consensus is what keeps this thing in check. Where if you mine a block, add a data, mine a block, and add it to a blockchain, all the people, all the users of the block will check, will validate, will verify whether the or wrong, and if it's right, they will agree that this is a right block. And okay, and if they reject, then cannot be added into a blockchain. Okay, so for that, a majority has to be achieved at the minimum percentage. People has to agree that. Okay, then we can add that to a blockchain. So this sort of prevents people coming and spamming any sort of putting any wrong or malicious data or adding wrong type of block and compromising the entire network. So this is what keeps it in check. So for this methods also, it's like if in your class you want to decide to go, you want to go to Goa or Shimla, you can have polls, you can have ballot, you can have lot picking, or any different types of method for coming to common agreement and checking the majority. Similarly, in blockchain, we've got some common types. There are a lot of consensus systems, but we'll cover this common one: POW, POS, and DPoS. POW is proof of work. Second is POS, proof of stake. Third is DPoS, delegated proof of stake. So we have 3 different consensus systems, and there are a lot of other also, but these are the commonly used ones. So I'm going to explain to you one by one and what are its advantages and disadvantages. Okay, what is proof of work? I got blah blah definition on the screen. I'm not going to explain that. I'm going to explain to you in very simple words. Proof of work is nothing but you have to do some sort of work, and you have to show the proof of that and get paid for that. It's like if you want to wrong, or if you want to add a block to a blockchain, whether you want to add a block or mine, to do is you have to first prove that you're a legit person. Okay, you're a serious person. It's like Google gives search a website showing you captchas to check that whether you are a human. So that is like proof of human. So here we have got something else, proof of work. So before mining a block or before voting whether a block is right or wrong, what you have to do is, before coming to common agreement, before coming to consensus, what you have to do is you have to solving a jigsaw puzzle, but not actually jigsaw puzzle, but a computational puzzle. Might be some very complicated puzzle involving a lot of mathematics, integration, calculus, or exponents or powers, a lot of stuff, even for which computer will take a couple of minutes. Okay, so you have to use your computational power, and you have to first solve that so that it shows that you are serious and you will not be spamming, or like you can set up a robot which will come and just mine a block and go. Because there is a time limit, you have to spend your computational resource, and it takes some time. You can just come and spam it. Okay, it's like consider without a consensus system, in every second, if one block is mined, in 1 minute 60 blocks will be mined, and millions of people are there. Everybody can come and mine, so that will spam the network. So to avoid this, we have kept a barrier. We have kept a eligibility criteria, where somebody has to come and solve the puzzle. The first one to solve the puzzle gets the chance to add the block or mine the block, and say whether it is a right block or wrong block. Okay, so you have to do that. So for that, you have to solve the puzzle. Puzzle is a computational. The work is a computational puzzle here. Okay, the problem with this is that Bitcoin uses this. So if you want to mine a Bitcoin and add it into a Bitcoin blockchain, you have to first mine it using proof of work. You have to solve that computational puzzle. And basically, I think it basically takes around 10 minutes for you to add one Bitcoin into the blockchain, one block into the Bitcoin blockchain network. Okay, so you have got that stuff. Then, yeah, the problem with the proof of work was that If you have high powered computer, then you could basically have higher chances of mining the block. So like it's not fair. It's partiality, or like people who are rich or people with high computational power can come together and can achieve the consensus, achieve the majority, and can agree to add a wrong or malicious block and compromise the entire network. So to avoid this, what we do is we came up with a different consensus system. Okay. Also, one problem is that more and more computer, like as people keep on increasing in the blockchain network, the complexity of the problem also increases. So more computational power is required, and so more electricity is burned for this. So it's not good for the environment. So ecologically, it is not good. So like more carbon footprints. So to avoid this, what to make it more energy efficient, we came with a new consensus called as the POS, or proof of stake. So basically, what it does is that you don't have to solve any computational puzzle or anything. Just you have to do one thing: you have to go to the market and you have to buy some cryptocurrency or token, and you have to deposit that as a safety deposit in the blockchain network before mining a block or validating a block. Okay, so you do that before that, like before doing that stuff. Okay, so once you put that security deposit and mine or validate the block and add it to it. So if you have validated a right block, a block with the correct data, then you will get your security deposit back. But not just that, you will also get reward for that. Okay, so this is that method to avoid spamming. So it's like having a college for free. Okay, so you don't take the education service, so you don't take the blockchain network for granted. System where you have to pay a security deposit, and you can then mine the block or validate the block and add the block to the blockchain network. Right thing of like telling the block is right, then you get rewarded for that. You get your security deposit back. And consider if you validate a wrong block, that data is malicious, which can compromise the blockchain network. If you do that, and rest of the people, when they find out, they happen is you will lose your security deposit, and you will also not get your reward. So this is a very good safety mechanism to avoid spamming and also to keep the integrity of the blockchain network maintained. So you will tell me that people who are rich can buy multiple accounts and what you call become validators, right? Put their safety deposit or security deposit and can become validators and add blocks, right? But the thing is that we have got very few number of validators in a blockchain network, and anybody can come and apply. It's like IPO for stock market. Anybody can come and apply for IPO, and a lucky draw is drawn, and only the lucky person, a couple of lucky people get the IPO. Similarly, here only the lucky people will get, randomly chosen people will get the chance to become the validator. Okay. There are very few chances all the validator who are chosen are coming with a malicious intent. Okay, there are very few less chances because nobody will risk their security deposit or their money. Okay, so randomly chosen. So there are very few possibility of wrong people coming together. Okay, and also because chances of losing your money, nobody is gonna do wrong transactions or mine a wrong block. That is why we use proof of stake. So what are the advantages over POW or proof of work? Better energy efficiency. You don't have to solve computational puzzles. You don't require 10 minutes like Bitcoin to add a new block. Lower barriers to entry. You don't need GTX or RTX graphics card like you required in Bitcoin. Stronger immunity to centralization. Like in POW with Bitcoin, there are chances like big people can come and buy thousands of computational rigs and can set up their own majority. So that centralization, the power goes to single entity. They can control the network. To avoid that, we have POS, strong immunity to centralization. Then there is stronger support for shard chains. I'll cover that later on. Okay, because it's a different topic. Shard chains is something that is growing at the moment. It's very emerging technology in blockchain. Okay, yeah. So the problem with POS also has problem. POS problem is that everybody might have the time to everybody might have the money to put safety deposit, but everybody doesn't have the time to put the money and sit and validate all the data. Okay, they don't have the time to do that. So we have got people who can go out for us, take our deposits and go out for us and act as a middleman for us and validate the blocks. Okay, It's like the election that happens in India, because you can't go out and do the administration or governance in your locality. You elect somebody, you delegate somebody, you cast vote for them. So similarly here, what you do is you delegate somebody to become a validator. So for that, what you have to do is you have to put your security deposit in that person's name, delegate him. Okay, so the person, the couple of people who get the maximum number of security deposit get the chance to become what do you call validators. Okay, so, and also not just that, there are a couple of other other what do you call parameters, like randomly chosen, then coin age, the ones who have deposited their security deposit for a long time. Like if you have deposited money with us for a long time, then it shows that you are more trustworthy. Okay, so all these parameters are taken into consideration. Then the person is delegated, and he validates the block. So if he validates the block right in the right way, then he gets the security deposit, his own security deposit, and the deposit of the people who have delegated him back, and also a reward. And the people who have delegated him also get a small chunk of reward from his portion. Okay. That's how DPoS works. So it's basically like the election that happens in India. Okay. So we covered basically three consensus systems: POW, POS, and DPoS, and we know why we should use each of them. Okay. The decentralization. This is one of the most important topic when it comes to Web3 or blockchain. This is what is the reason behind us, the internet or the modern people choosing blockchain. Decentralization. What exactly is decentralization? I've got again definition on the internet, sorry, on the deck on the screen, but I'm not going to read that. Decentralization is basically that Facebook, Instagram, WhatsApp is a centralized system where a single entity, single tech giant controls everything. They have their own servers, infrastructure setup. So they can basically stop the service at any time. They can check whatever the data is going through it. Cambridge Analytica data leak, Facebook hacks, Facebook tracking you, big tech giants tracking you. This is because this is due to the fact that the entire system is centralized. Okay, so a single entity is controlling the entire network. That is the problem. So we can avoid this. How? By distributing the power among all the users of the internet. So it's like you, me, and all the other million people who are using Facebook and blockchain. We are the people who will be controlling it, and it's like our computational resources will be used to run this network. So we don't need tech giants like Facebook or Google or anybody. Okay, and because we are running this network, we don't have to worry that Facebook or Google or anybody can steal our data, check our data, hack this. Okay, it's decentralized, and one advantage is that more reliable. How more reliable? Recently there was a social media outage due to BGP, it's Border Gateway Protocol. That's a problem that happened with Facebook back, like a quarter back, like around 6 months back, not 6 months, but 3-4 months back. That was that happened basically in their infrastructure setup. So what happens is, if that single building which holds all this infrastructure or the server, if any disaster happens there or any issue happens there, the entire system can go down. So the reliability is very low because you are depending on a single entity and their single infrastructure. Okay, consider they might have a couple of more infrastructures, like 5 or 6 more infrastructures across the world, but still it's very less compared to the number of people are in the world. It's very less. So the reliability is less. But consider all these millions of people using the network, only using their computation resources to run this network. So we have got millions and millions of people running this network. So even if lakh people go offline, don't share their computational resources, still the network will be running. So it's like, even if somebody has not came because they are sick, you don't have to worry. You don't have to worry because the rest of the people will take care of the network. Okay, so that's more reliable than the centralized infrastructure. You don't have to fear about a single point of failure. Okay, then next thing, more security. Now we will say earlier we only had to fear that Facebook or Google will steal our data, but now every single people on this network are hosting this network or are part of network, so they can access our data. No, they can't access your data. This is more secure because each and every block storing your data is secured using cryptography and something called as SHA-256. Okay, secure hashing algorithm, 256 bits. It's very top class, top of the line security, cryptographic security, where if you use that security, it will take you your 4-5 generations to break that network, like 300-400 years, okay, for you to break that. That's very tough. Don't know when the supercomputers come. Probably there might be a chance that SHA-256 can break. If that happens, then probably every network, even the military level network, could break. Okay, but research is going on to build what do you call supercomputer proof or quantum computer proof uh, hashing algorithms or cryptographical systems. Okay,
Hey, Jobin, sorry to
yeah,
interrupt, but I guess your slides are stuck. So, can you please reshare your screen?
yeah, sure. Give me a second.
Yeah.
What about now?
Um I can't see your screen.
Okay, give me a second. Right now, is it
Yeah,
visible?
Yeah,
yeah,
it's
that's
visible.
it.
Fine, it's fine.
Okay, so yeah. So now you also can see the a pictorial representation of how decentralization looks like. Okay, it's like distributed. So high reliability, high security, because it's like your data is encrypted in a briefcase and been thrown outside to millions of people, and you only know the key of that briefcase, so nobody else can open it. Only you can open it. Okay, it's like that. Okay, so you don't. So even in case uh, the problem with system was like your data was in a briefcase, secured, but the and Facebook also knew the key, so they can also even open it and see what the data is. Facebook loses the briefcase, you lose your data. So that was a problem. But when it comes to decentralized blockchain networks, it's like I got millions of copies of briefcase with your uh, key or password. So only you can open. And even in case like 10-20 briefcase get lost, the rest of the briefcases are available with all your data. So more reliable and decentralization provides. Okay. That is why you should choose a decentralized system over the centralized social media, centralized storage providers like Google, Azure, and all the systems. Okay, can go down anytime. That's why you see lots of show you outages. You can see most of the websites that show outages are centralized, based on centralized infrastructure. There are very rarely shown cases of outages in decentralized systems. Okay, yeah. So I hope that that has made decentralization clear. Okay, so I told you what a decentralization, what are the features of the blockchain, advantages, and everything. But how you could leverage all these features of security, reliability, because Bitcoin just provided you with financial functionality, nothing more than that. You could just use that for trading, buying, or selling, all that stuff. Okay, just an alternative for your money. We wanted to leverage this so that you can solve the problems in the internet, build on internet. So that's when a network called as Ethereum came up with a concept of smart contracts. Smart contracts are something that brought the functionality of smart programmability or logical programmability to blockchain. So you have got all the added features of blockchain like security, reliability, decentralization, everything with added advantage of logical programmability. Now you can program it like any other languages, like building on any other languages like JavaScript or anything. Okay, Go, JavaScript, Rust, Perl, Scala, or whatever it is, C, C++, anything like that. So you got that functionality of logical programmability. So that was brought using smart contracts by a network called as Ethereum after Bitcoin. So now you could program things and give them all these features sorry, that Bitcoin had. Okay, so the smart contracts, the example is here. This is a very small example of smart contract to store simple data. Okay, a simple smart storage, simple storage, what do you call, code of a smart contract. And the smart contracts are written in a language called as Solidity. So you can see the Solidity smart contracts, like it's very small compared to the typical uh, programming stuff. Okay, it's very short, very small. Okay. Uh, Another very simple explanation I can give to you of what exactly smart contracts are. Smart contracts are like vending machine, as it is written on the definition. Here it's like Coca-Cola vending machine. So if you want a Coca-Cola bottle or a Coca-Cola can, you come here, you pay a couple of bucks, and you get it dispensed. Okay, that is how it works. So smart contracts are nothing but it is programmed in a such a way that if certain criteria is met, you receive certain input, then it is programmed to give certain output. It's like, give me 10 rupees, I will let you download this image, or I will let you download this video. Okay, best example is like build a smart contract based on Amazon Prime or Netflix, where you write that pay me 499 rupees for this movie and you will get the chance to download this. Okay, so like very secure. You can't what do you call, do piracy with this. It solves basically the problem with the piracy. Okay, so can have that system here using smart contracts. Okay, it's simply remember, smart contracts are nothing but vending machines which take certain input or has to meet certain criteria. Once the criteria is met, it gives the output. Okay, it dispenses that, and it runs on the blockchain network, and it's written using a language called a Solidity. Yeah. Then what? DApps. So we wrote the code, the logical part. So now when you add a front end to that, a React or a Vue.js or what do you call, AngularJS, whatever the framework you want to use, you use that and you build the front end, or HTML or whatever it is, you use that and build the front end with this logic that you have written with smart contract. Then this combined package is called as DApps. The normal ones are called as applications, but in blockchain, such applications are called as DApps, or decentralized applications, because these applications run on decentralized blockchain networks and are written using smart contracts with a front end user interface. Okay, this is the advantage of having DApps. Is exactly same like having a blockchain network: reliability, security. Okay, the same advantages having decentralization. So you have zero downtime, better privacy, censorship free. So if Facebook decides to kick, like Twitter decides to kick Trump because they own it, they can kick. But if it's a decentralized network, you can't do that because it's censorship free. Or the entire community has to come together for the common consensus that this person is a malicious person with a malicious intent, and he is not the right guy to be added into the network, so he can be removed. So like a single big entity cannot censor it. Okay, there's a complete data integrity, verifiable behavior, because you can verify each and every transaction. Okay, yeah, that's the advantage of DApps. So you can build any sort of application with this technology. Like you can build a Instagram DApp, Facebook DApp, Skype, Discord, YouTube, Spotify. A lot of services are already available. Like for YouTube, decentralized YouTube is available. Decentralized Spotify, it's called as Audify or something like that. It's already available. A lot of systems have started becoming decentralized because of its advantages. So these are DApps. Okay. Then next is Web3. So this entire concept of blockchain and all this are present in a generation called as Web3. Okay, we were in Web 1.0, which was the earlier generation where we had desktop-based browser access, dedicated infrastructures, and e-commerce websites, like the time when Amazon was invented. Okay, the Amazon which sold books. Okay, that was the Web 1.0. The Web 2.0 came, it had social media, then cloud computing, all this stuff. Okay, the Facebook, Instagram, and all this was in the Web 2.0 era. Now is Web 3.0, which is basically driven by bleeding edge technology like blockchain, AI, edge computing, and decentralized data architecture and all this stuff. Okay, so the best technologies run this new generation of web. So welcome to this new generation of web. Be a part of it. You know, when the internet came, the .com came, all the people who were a part of that at that time are now in like great heights because they rode the right wave, because they knew that was a future. Okay, we had a .com bubble bust, but who the ones who made great projects, who worked in a great company, had a great foundational basics in terms of that technology that they have learned when they came to know about Web 1.0, are now big companies and big tech giants and big CEOs. Okay, so now you are in that situation like the .com era. You are in that beginning era of Web 3.0. So if you start to learn all these technologies right now, then you can be part of uh, big future technological companies, or you can build your own technological companies, startups, and a lot of big projects. Okay, that can be the future. So be part of it. Start learning blockchain. And why? Because Web3 is the future, is the modern internet that is open. Anybody can be part of it. No single entity controls it. It's trustless. Like, because there are decentralized banks right now, so you don't have to trust on SBI or any private banks or government banks to give you loans. It's automatically programmed smart contract where you come and deposit your collateral or your whatever it is as a deposit, like your land papers or anything. Smart contract will verify it with all the government services, or your papers or whatever it is. It will verify it, your Aadhaar card or anything. After verification, if it finds that you are eligible, then it will release the money. So you don't have to rely with any person or any bank officer. You don't have to bribe anybody. So future is trustless, permissionless. You don't have to take permission from the bank. Okay, you don't have to worry about that. So it's open, trustless, and permissionless. So that is what the Web3 is. Blockchain powers it. So be a part of it. Then next, small confusion is Web3.js. So don't get confused between Web3 and Web3.js. Web3 is the era. This is the new generation. Web3.js is a library, JavaScript library, which acts as an interface between your backend, the blockchain stuff, and your front end. Okay, that's Web3.js. So don't get confused between these two terms. Yeah. So next, Ethereum. Like I told you, smart contracts were brought into play with this blockchain network called as Ethereum, which is a popular blockchain network which uses proof of work consensus mechanism with smart contracts. And I told you that you have to pay, like you have to give certain input. Like if you are building a smart contract for movies for Netflix, Amazon Prime, so you have to pay certain amount of money. So in Ethereum, smart contracts has certain amount of fees. So if you are using smart contracts, you have to pay a certain amount of fees, and that is paid in the native currency of Ethereum, like Bitcoin has BTC. Here we have got ETH. ETH is a currency. Using ETH, you have to do all the transactions in the Ethereum network. Okay. So Ethereum is right now using proof of work, but in the Ethereum 2.0, they are coming with POS, proof of stake, because they know that's better. That's the future. Okay. So you have the advantage of smart programmability, which Bitcoin doesn't have, and proof of stake also is coming. Then that's the best combination that you can get. The next, yeah, that's the scene. Then applications. What all are the verticals which can be influenced by, like, that influences the blockchain influences? Okay. Other than cryptocurrency, finance, and all this stuff. Okay, because it brings privacy, transparency, and all this stuff into play. So what are the things? The 5 major verticals are supply chain, finance, healthcare, retail, government, and government. Okay. So supply chain, how? Consider you build a smart contract for refunds of your e-commerce orders from Flipkart or Amazon. So you don't have to worry about refunds. You don't have to worry whether you don't have to wait for the merchant to get the product, check whether the product is right or wrong, and deposit or give back your money. You can have smart contract which will check for the photo of the product if it is right, in the right condition. Probably a machine learning will check whether it's right, and if it's right, then instantly within a second after it has been received by the delivery boy or the pickup guy, it will initiate the refund process. So it will not take the typical 7 to 8 business days stuff. Instantly, within seconds, your refund will be initiated and you will receive the refunds. So that's how blockchain can be helpful. Can build smart contracts for that. Each and every single services in supply chain can be modernized using smart contracts. Okay. Transparency can be brought, traceability can be brought, frauds can be reduced. Okay. Then there is finance. I told you, you don't have to depend on banks for loan. Smart contracts can be made for loans, okay, which will check your criteria, your papers, and everything. If it's verified, automatically it will dispense you the money. Then healthcare. Healthcare is, health data is very valuable for big companies. So they have been always, many of you might be using a lot of smart bands. So they're selling these bands for so cheap because they are harvesting your medical data, how you're running, how your heart works, all this data, and they're selling this to big companies as a data set. Okay, so your data is very important. So you can now more modernization of hospitals and healthcare systems are coming. So then this is very important. You don't want others to know about your diseases or your personal problems or your healthcare thing. Okay, so there we can use this thing. Then retail, better inventory management, faster settlements, the refund one, less paperwork, because no paperwork signing is required. Smart contract will handle everything. Okay. Then government, the best example I can tell you is elections. Replace EVMs with smart contracts using DPoS, delegated proof of stake, you will have the best corrupt free elections in India. And I believe you guys who are attending this session from IIITM are the ones who are going to be building this future, are going to be the ones building the future election systems and government administration systems. Okay. So you don't have to depend upon EVM machines. It can be hacked or anything can be done. It can be manipulated. Votes can be anything can be done. But when with smart contract, you can set up a DPO system, delegated proof of system. You can come and vote. Okay, and it can also be transparent so that at the end of the result, the smart contract will print out how many people have voted for this party. Without, you can make it in such a way that you can't reveal the person's name or the voter's name. So that can be done. Okay, so transparent but 100% reliable and corrupt-free election system or voting system can be made using DPoS based this smart contracts. Okay, then what do you call better control, better transparent processes. Just think about having to go to passport office and create your passport or getting your birth certificate and all this stuff. So difficult. You have to meet so many people, pay some of them bribe and all this stuff. So many things can happen, and it's been happening for years and years, even after computerization or modernization. You can avoid that. Replace that one single guy who is writing your death certificate or birth certificate or your marriage certificate or your any government document with a smart contract. You submit all your documents that is required for you to get this particular document. The smart contract will verify it, and if it's meeting all the eligibility criteria, it will instantly send you the document. That's how simple it is. And anytime you can validate that also, because it's on blockchain, it's stored on blockchain. You can't manipulate, you can't forge it, you can't do fraud with it because it's made on blockchain. So you can check when the transaction was done, when the document was created, all this stuff. Okay, so better government administration, better government like your what do you call your graduation certificates, better election, all this can be made. You can have a better governance in India using blockchain. So that is why people are calling blockchain is the future. That is what will power the modern internet. And now you know why you should learn blockchain. Okay, so that's all, folks. For but please do wait. We have got something more. Don't leave. Okay, that's all for this deck. But other than that, we have got something. Give me a second. For all the people who have attended this session, okay, if you have liked this session, you can take a snapshot of any of this session, like from the session, any of the part which you liked the most. You can take the snapshot of that, and something that you liked, you can share that, tagging us on Twitter. And if you do that, we'll select a couple of people from this session and we'll ship out to you a bunch of swags, like probably Arcana goodies, like Arcana bottles or t-shirts or swags and stickers and gift hamper or something like that. Okay, so if you like this session, if you feel that you have got enlightened with blockchain, you have broken, like breaking into blockchain was success, you broke and you are inside that, you have got all things clear, then you can for sure share the feedback, get the swags, make sure to tag us. I'll share our Twitter handle with you. Give me a second. This is so that we can know about the feedback from your end. So, and also incentivize you for that, doing that. So I have shared that in the chat section. You can visit our Twitter website, Twitter handle, and tag us and share the screenshots with comments about the feedback. Which part did you like the most? What are your plans? Do you have any ideas? Do you have any questions? Tag that. The best questions or the best feedbacks will receive swags. We'll ensure that all of you will try our best to send out swags to all of you. Okay. And before leaving that, if you are interested to learn more on blockchain, if you wish to learn more on blockchain, then you can do one thing. Here is our link to cohort, which is like a 14 days or a 1 month program. I've shared it in the chat section. You can visit this form and you can fill this and contact us using our Discord. Okay, so you can visit us. Give me a second. I'll share that. So you can fill the form, you can join our Discord and let us know whenever you want to start the cohort. We'll take you from zero to hero in blockchain. We'll help you build great projects for free, with great mentoring, with great amount, good resources and all this stuff. So be part of our Arcana Developer Guild. That's what we call it. So join us, fill this form, and make sure to give us your feedback also. And give me a second. Give me a second. Yes. Yeah, and all the people who are attendees for the hackathon, the HackStack, if you have any requirements for building on, just a second. Yeah, if you have any requirements for building on storage and authentication, go out and check our website testnet.arcana. Here you can come and easily use our what do you call our solution for your storage and our authentication services. I'll share that. Give me a second.
Have you shared all these links in the YouTube chat, Jobin?
Yeah, I've shared there. So if you're interested, it's
I think
code is free.
I think the links the links are not visible yet. I think you've shared them somewhere else, or can you share that in the private chat so that I can drop it over there?
Sure. I'll share that. Yes. That's one. That's for the Twitter handle. If you wish to get swags, give us the feedback on that. And this is the form to the code. If you wish to join and learn and go from zero to hero in blockchain, be a part of this Web3 revolution, then fill the form and then join our Discord channel and let us know when you want to start. Okay. That's the thing. And then this is our dashboard. Okay. I hope that you can see our dashboard. Come here, just click on Google. Okay. And just sign in. Sign in and give me a sec. I've already configured one. I'll just delete it. Yeah. So once you sign in inside Google, you'll get this message. Just click on configure. Whatever project you're building, consider it's a decentralized Instagram. So give it the name D-Insta. Select the region which you want, whatever it is. Click next. Which chain or on which network you are building, click on that. If you don't want to choose it now, you can skip that. Check the authentication you want. If you want to log in with Google, GitHub, Reddit, Discord, whatever it is, click on that. You want the storage unlimited right now, click save, and that's it. Your storage solution, your storage requirement using blockchain is done. It's set up. It's done. And now you have a complete console where you can see the number of people who have registered and are using your application, and how many files have been uploaded, and what the bandwidth, what's the storage, the actions involved, all these things you can see here. That's how simple it is. You can easily implement this. And if you want to see the backend implementation of this, go check out this docs, click on the docs button, and this will open up our documentation. See, this is the documentation, docs.arcana.network. Click here, visit it. There's a complete instruction given here with very easily. It's given here. So you can check out that. And also there is a demo app. So you can check this one and understand how the authentication and the storage solution has been implemented in this demo app. Okay. And if you have any doubt, please feel free to reach out to us on our Twitter handle. And if you want to reach out to me personally, then this is my handle. Give me a second. You can reach out to me on Discord also. If you want to reach out to me on Twitter, then this is my handle. I've shared it on the YouTube comments. You can feel free to reach out to me. Okay. Yeah, I'll help you out with any projects, hackathon, mentoring, or if you want to learn more or anything, any possible help. Okay, I'll help you out with that. Okay, so I hope that the session was valuable, enlightening. If you guys have some feedbacks, then feel free to share it in the YouTube chat section until the event winds up, or feel free to share the feedback feedback on our social media, the Twitter, so that you get the swags. Until then, bye-bye. I hope the session was great. Thanks.
Yeah. Thank you very much, Jobin. I think that was a lot of good info for all the newcomers that have recently joined the blockchain world. And I think the session will definitely act as a head start in their journey. We're glad to have you as a part of HackStack 2022, and thank you again for like giving us your valuable time and organizing this entire session. Thank you very much.
Thanks a lot, and all the best for your hackathon.
Sure. Thank you very much. And thank you to everyone who attended the session and stayed till the end. I've dropped all the links that you shared in the chat. Make sure you take a snapshot and tag Arcana Network and Jobin himself on Twitter so that you can grab some good goodies. Yeah.
Bye, guys.
Thank you.